We're going to use light to look at the colour of your blood as you're exercising. Many people are familiar with the idea of using visible light to look at processes within the body. For example, arterial blood appears bright red because it contains lots of oxygen. Venous blood appears blue because most of the oxygen has been taken from it. So we can use visible light systems to look at the colour of blood and work out how much oxygen it contains. Our exhibit is all about new technologies using near-infrared light sources to look through much wider sections of tissue. So we're able to look through whole sections of brain, particularly the brain of a premature infant, and also through the muscle and also through the breast.
The main advances which have led to this area becoming so interesting are new laser sources, for example, new detectors, as well as new computing technology which enables us to perform types of imaging that previously we're not able to do.
Many people are familiar with technologies like X-ray imaging, ultrasound, but there are very few people that associate those technologies with medical physicists. So we're here as a group of medical physicists and bioengineers showcasing what we're doing to improve healthcare in terms of developing new technologies that will soon become routine in hospitals around the world.
What we're trying to do with this model is
if you have a premature infant and it goes on a neonatal intensive care unit, there are no other monitors currently available that allow us to look inside that baby's brain and see what's happening to the blood and oxygen distribution in that baby's brain. That information is critical in helping doctors decide whether it may be susceptible to brain damage. Equally, if you're an adult and you have a head injury, if you go into a neuro-intensive care unit, many of the techniques that are currently used are invasive. They're literally putting probes directly into brain tissue. Our technology is completely safe and completely non-invasive and allows us to make measurements of what's going on inside the brain without actually damaging the skull, the skin or the brain at all.
The focus of our work over the next few years is really to transfer this technology into the hospital, to provide tools that doctors can really use and to make a real difference in the NHS and not just in the research lab.